Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of coding alone versus coding collaboratively. We'll explore the advantages and disadvantages of each approach, discuss best practices, and illustrate with code examples to help you understand the practical implications. Coding alone, the lone wolf approach. A description. Coding alone is the traditional approach where a single developer is responsible for designing, implementing, testing, and maintaining a piece of software or a project. It's the default mode for many independent developers, small projects, and personal learning endeavors. B advantages. 1. Focused concentration. Working alone minimizes distractions and allows for deep focus, critical for complex problem solving. You can get into a flow state more easily, leading to increased productivity. 2. Individual control and ownership. You have complete control over the architecture, style, and implementation details. This fosters a sense of ownership and pride in the work. You can experiment and explore solutions freely without needing consensus. 3. Faster decision making. Initially, you don't need to consult or debate with others, allowing you to make decisions quickly and move forward without delays. This can be a significant advantage in time-sensitive projects or when exploring rapid prototypes. 4. Learning through trial and error. You are directly responsible for every aspect of the code, which forces you to understand the intricacies of the system more thoroughly. Mistakes become valuable learning opportunities. 5. Improved time management. You can structure your time as per your own needs and liking, ensuring that you are working at your productive best. See disadvantages. 1. Limited perspective. You are limited by your own knowledge, experience, and biases. You might miss alternative solutions or potential pitfalls that a fresh perspective could identify. 2. Risk of burnout. The responsibility for everything can be overwhelming, leading to stress and burnout, especially on larger projects. There's no one to share the workload or provide support during challenging times. 3. Slower debugging. Potentially debugging your own code can sometimes be harder because you are too close to the problem. Another person might spot an error more quickly. 4. Knowledge siloing. The knowledge of the code base resides solely with you. If you leave the project or become unavailable, it can be difficult for others to understand and maintain the code. This creates a bus factor risk. What happens if you get hit by a bus? 5. Inconsistent code quality. Without peer review, it's easier for bad habits to creep in, and the overall code quality might suffer. Consistency in coding style and architecture might be lacking. D. Best practices for coding alone. 1. Plan and design. Even for small projects, before you start coding, spend time designing the architecture and data structures. A well-thought-out plan will save you time and effort in the long run. Use tools like flowcharts, UML diagrams, or simple sketches to visualize your design. 2. Write clear and concise code. Follow coding style guides, example PEP 8 for Python, Google Java style for Java, and use meaningful variable and function names. Write comments to explain complex logic and assumptions. Remember that you are writing for your future self. 3. Use version control. Git is your friend. Use Git to track changes, experiment with different approaches, and revert to previous versions if necessary. Create meaningful commit messages to document your changes. 4. Write unit tests. Test your code early and often. Unit tests help you verify that your code is working correctly and prevent regressions when you make changes. This will also help you refactor the code easily. 5 Regularly refactor your code as you learn more about the problem domain and your code evolves, refactor it to improve its structure, readability, and maintainability. Don't be afraid to rewrite code that is poorly designed or difficult to understand. 6 Take breaks and step away. When you are stuck, take a break and step away from the computer. A fresh perspective can often help you find the solution. Get enough sleep and exercise to maintain your physical and mental well-being. 7 Seek external help when needed. Don't be afraid to ask for help on forums like Stack Overflow, Reddit, or developer communities. Explain your problem clearly and provide enough context to allow others to understand it. Code example, Python, simple todo list. Explanation of the code classes todo item represents a single todo item, and todo list manages the list of items. Methods each class has methods for adding, removing, viewing, and marking items as complete. Main function the main function provides a simple command line interface for interacting with the todo list. Input validation basic input validation is performed to handle invalid user input. Readability the code is structured with clear variable names, comments, and indentation to enhance readability. 2. Coding together, the collaborative approach. A description Coding together involves 2 or more developers working collaboratively on the same code base, often in real time or near real time. This can take various forms, including pair programming, mob programming, code reviews, and collaborative design sessions. B advantages 1. Knowledge sharing and cross-training. Collaborative coding facilitates the sharing of knowledge and skills among team members. Junior developers can learn from more experienced ones, and everyone can gain a broader understanding of the code base. 2. Improved code quality. Code reviews and pair programming help to identify errors, bugs, and potential problems early on. The collective wisdom of the team leads to better code quality and more robust software. 3. Reduced bus factor. Knowledge is distributed across the team, reducing the risk of losing critical information if a single developer leaves the project. 4. Enhanced creativity and innovation. Brainstorming and collaborative problem solving can lead to more creative and innovative solutions. Different perspectives can spark new ideas and approaches. 5. Increased team cohesion and communication. Working together fosters a sense of teamwork and camaraderie. Regular communication improves collaboration and reduces misunderstandings. See disadvantages. 1. Communication overhead. Collaborative coding requires more communication and coordination, which can slow down the development process. Meetings, discussions, and code reviews take time and effort. 2. Potential for conflicts. Disagreements over design decisions, coding styles, and implementation details can lead to conflicts and delays. Effective conflict resolution skills are essential. 3. Personality clashes. Incompatible personalities or working styles can create friction and negatively impact team morale and productivity. 4. Groupthink. The desire to conform to the group can stifle individual creativity and lead to suboptimal solutions. 5. Scheduling and coordination challenges. Finding mutually convenient times for meetings, code reviews, and pair programming sessions can be challenging, especially with remote teams. D. Types of collaborative coding approaches. 1. Pair programming. 2 developers work together on one computer. One person, the driver, writes the code, while the other, the navigator, reviews the code in real time, provides suggestions, and thinks about the overall design. They switch roles frequently. 2 Mob programming *. The whole team works together on one computer, with one person typing and the rest providing guidance and suggestions. The driver role rotates frequently. 3 Code reviews *. Developers submit their code for review by other team members before it is merged into the main code base. Reviewers provide feedback on code quality, style, and potential issues. 4 Collaborative design sessions *. The team works together to design the architecture, data structures, and algorithms before any code is written. This helps to ensure that everyone is on the same page and that the design is sound. *E Best practices for coding together. 1 Establish clear communication channels. Use tools like Slack, Microsoft Teams, or other collaboration platforms to facilitate communication. Establish clear guidelines for how and when to use different channels. 2 Define coding standards and style guides. Agree on a coding style guide and stick to it consistently. Use linters and formatters to automate code formatting and enforce coding standards. 3 Use version control effectively. Use Git for version control and create meaningful branch names and commit messages. Follow a branching strategy, example Git flow, to manage different features and releases. 4 Conduct regular code reviews. Make code reviews a regular part of the development process. Provide constructive feedback and focus on improving code quality. 5 Practice active listening and respectful communication. Listen carefully to others' ideas and perspectives. Communicate respectfully, even when you disagree. Avoid interrupting or dominating conversations. 6 Be open to feedback. Be willing to accept feedback on your code and ideas. Don't take criticism personally. Use feedback to improve your skills and the quality of your work. 7 Use collaborative coding tools. Utilize tools like Visual Studio Code with Live Share, Google Docs, for design documents, or online whiteboards like Miro to facilitate real-time collaboration. Code example, pair programming, JavaScript, basic calculator. Let's simulate a simplified version of pair programming, showing how 2 developers might work together. We'll focus on the iterative process and the communication. Developer 1, driver. Communication between Developer 1, driver, and Developer 2, navigator. Navigator OK, the initial add function looks good. Let's add a subtract function as well. Driver sounds good. I'll implement the subtract function next. Developer 1, driver. Communication navigator the subtract function looks correct. Now, let's think about input validation. What if we pass non-numeric values to these functions? Driver that's a good point. We should add some checks to make sure the inputs are numbers. Developer 1, driver. Developer 2, navigator. The type validation looks good. Let's also include test cases to verify those error cases. Explanation of the pair programming example iterative development the code is developed incrementally, with each function being added and tested before moving on. Real-time feedback the navigator provides real-time feedback and suggestions to the driver. Input validation the team identifies the need for input validation and implements it to handle invalid inputs gracefully. Test-driven development, simplified test cases are discussed and added as the code evolves. Communication the communication between the driver and navigator is crucial for ensuring that the code is correct and meets the requirements. 3. Choosing the right approach. The best approach, coding alone or coding together, depends on several factors. *** project size and complexity * For small, well-defined projects, coding alone might be more efficient. For large, complex projects, collaborative coding is often essential. *** Team size and experience * If you are working in a large team with diverse skill sets, collaborative coding can be highly beneficial. If you are a solo developer or working in a small team, coding alone might be more appropriate. ** Time constraints * If you are under tight deadlines, coding alone might seem faster initially, but collaborative coding can ultimately lead to higher quality code and fewer bugs, saving time in the long run. ** Learning goals * If you are trying to learn a new language or framework, coding with a more experienced developer can be a great way to accelerate your learning. ** Personality and working style * Some developers prefer to work alone and enjoy the autonomy. Others thrive in a collaborative environment and enjoy sharing ideas and learning from others. Summary table. Feature coding alone, coding together. Focus deep, uninterrupted, shared, collaborative. Control complete, individual control, shared control, consensus driven. Knowledge limited to individuals' expertise, collective team knowledge. Code quality depends on individual practices, potentially higher due to review. Risk, bus factor, high, knowledge siloing lower, knowledge distribution. Communication minimal, high, requires effective skills. Creativity, individual innovation, collaborative brainstorming. Speed, initial, faster decision-making, slower initially, faster later. Best for small projects, individual learning, large projects, team environments. Conclusion. Both coding alone and coding together have their own advantages and disadvantages. The key is to understand the strengths and weaknesses of each approach and choose the one that is best suited for the specific project, team, and individual involved. Often, a hybrid approach is the most effective, where developers alternate between working alone and collaborating with others. Remember that coding is a continuous learning process. Regardless of whether you are coding alone or coding together, always strive to improve your skills, learn new techniques, and write clean, maintainable code. Good luck.